I welcome everyone to the master thesis defense of Imtiaz Udin. You can already see the title of his master thesis, Visualization of Spatial Disparities in Mobility Service Frequency with Open Public Transit Feed Data in Germany. The work was, or the topic was provided by the IER, Institute for Ecological Space Development. And yeah, the committee is complete, I think, so we can start. Please, Imtiaz, the floor is yours. You have 15 to 20 minutes to present your research results.
Thank you, Dr. Burgert. Welcome everyone in my presentation. The presentation topic is visualization of spatial disparities in mobility service frequency with open public transit feed data in Germany. This is the outline of the today's presentation. I'll go through one by one. Firstly, I want to draw attention about the open data. This is a publicly available data which are collected and disseminated without any restriction. And GTFS data is a type of open data, which is in full form, generalized transit feed specific data. And it provides hourly information, and there are some restrictions in the data format. For example, preparation and harmonization of the data. And with the GTFS data, one can explore spatial disparities. Before that, I want to say what is mean by spatial disparities. It is the observed differences in infrastructure, economy, or any other kind of things that observed in a spatial area. And with the spatial disparities for this study, we mean that the difference in mobility service frequency. From the existing applications and the studies found on the mobility service frequency and using the GTFS data, it is seen that there is a gap of visualizing attempt in this sector. So this thesis is started with the visualizations development. And for the terminology, I want to say about the public transit, transport and transit is used vice versa in different format, and public transport is used in Europe. On the other hand, public transit is used in mostly North America and Southeast Asia. And the definition of public transit frequency can be the number of times for an hour that a transit service user has access to transit mode. In my studies, I have used mobility service and public transit as vice versa. So let's talk about the research objectives. There are 3 research objectives, which is the first one, to identify and determine the methods of exploring spatial disparities. We have 3 research questions here. First one is to method the explore spatial disparities, and then finding the available tools that use GTFS data, and then the user requirements and design parameters for web map-based visualization. The second objective is to adapt open source data for the visualization. And the research questions are the integrations of GTFS data in best possible spatial resolution. Also, the second research questions in this objective is the challenges to harmonize this multi-source data. The last research objective in the study is to develop and evaluate a tool for interactive web map-based visualization. And the research questions are the development of the web map-based visualization and then the evaluation outcomes. So this is the methodology I have followed throughout the study. First, I have attempted the theoretical approach, then I have collected data and processed the data, then I have started the design and evaluation of the tool. So from the systematic literature review, I have collected the literature related to spatial disparities in public transit from 2 sources, Web of Science and Scopus. In the right side the figure, we can see the cluster-wise co-occurrences of auto keywords in public transit, mobility, public transport, and spatial equity. This proves that the search are found, which is really related with the special disparities in public transit. And from the collected literature, I have gathered the informations in 3 different criteria: tool, statistical analysis, and visualization. In the literature, they have used OpenTrip Planner as a tool, and S3 network analyst, and also the graph-based network analyst. The statistical analysis mainly measured is the central tendency. Then they also used dispersion and variability. Also, they have used local Moran's index in their studies. The visualization techniques mostly found are graphs and maps. In the right side, figure 2, we can see the transit and auto accessibility ratio. And this technique is used to show disparate frequency indicator in the tool. And then the local Moran's index results. This example also used in the visualization tool. There are 3 existing applications which is mostly related with the study I found. First one is PUPTAD-VIS that show mobility, speed, flow, density, and headway and analysis of the transit service. And in that tool, side-by-side evaluations can be possible. The second one is Swiss Railways Network that they offer 3 base map. They have overview map and they have color difference in different mode of transit service. And the last one is Travik. They have 6 base map. They can, in that application, users can do overlay, and then they can also differentiate between different transport mode. For the design principles, there are some map elements for example, map title, scale, and supplemented information and graphs, labels and legend, menus. And there are 2 types of cartographic interaction operator primitives, which is one is work operators, another is enabling operators. And from the work operators, zoom, search, overlay, reproject, these things I think it's important. I have also included them in the tool. And in the enabling operators, import, export, save, I have only added the download options in my tool. And in the user-centered map design from the Robinson, I have adapted this procedure to develop my tool, which I will be discussing details in coming slides. So about the data, there are 3 types of data I have used in my studies. The first one is general transit field specification data. I have used local transit data and also the regional trains data. And then the street network data, which is offered from OpenStreetMap. And then the administrative data, I got it from Federal Agency of Cartography and Geodesy. For the result of the first research question 2A, I have processed this collected data in different level, and then finally when I finished all the processing, I have also developed the tool to further process this GTFS data for the new data. So this is the result for station level frequency calculation in the left side, and in the right side the workflow for to calculate frequency indicator and disparity index from GTFS data. Now I want to talk about the methodology of the design and the design interface which I have created. I named it as PUPTAD-VIS visualizations. The visualizations method started with work domain analysis. From work domain analysis, I have found the relevant requirement and also the offers for the users how many things I have to offer. That things is done from the literature review and also analysis of existing applications. Then I have started with the conceptual development. The first idea I have listed the functionalities. Then I have made a layout in the mockup. Then I have developed the first prototype when we had the meeting with supervisor. Then I have reviewed and also integrated the comments from them. The third step is the design of data. I have created 4 web map, and in those web map, I had also included group layer. Layers are grouped into, and then also users can see the different range of layers visibility, because not every data need to be shown in every scale. And for users also, there's a pop-up for every map group. And the data visualizations is mainly on the map basis. There are 3 kinds of maps in the tool: dot map, heat map, and choropleth map. The data aggregations are done on the basis of special aggregations, and there are 2 types of special aggregation used in the tool. One is administrative boundary base, which is state and municipalities, and another is 1 kilometer grid based. So now I want to show the tool, and here we see the demo. So this is the interface of risk visualization, which is the short form of public transit disparity visualization. In the menu bar, you can switch to comparison window, which I'll show later, and then you can also go to the details about the tool and then the user guide. Let's continue with the collapsible sidebar, which is in the left side, and you can filter for a specific state. The next option is filter options for municipality. Now I want to show you the map navigation panel. Here the local transit service frequency map. Here is the regional transit service frequency map. Here is the raster in 1 kilometer grid map. Here is the disparity index map. The search function, you can search for any place, and here is the legend panel. You can see the legend, and then this is the layers panel. Now I want to show you the indicator panel. Here is the indicator panels. We have 24 indicator tab here. There are 12 chart like this, and then 12 tables. Total number of frequency per hour is shown according to the municipalities. The tables, which is a frequency indicator, is related with the raster 1 kilometer grid. These groups of tables are related with the disparity index map group. Now I want to show you the filter function for state. Let's select the states. Let's say for Saxony. Now we see the frequency only for Saxony, and here we can see the total number of frequency per hour, and also in this panel we see the frequency per hour by municipalities. We can select a municipality. Let's say for Dresden we want to see. Now the information has changed, and only the frequencies with Dresden is showing in the map, and also the information has been changed here. The next interactive elements is layer visibility. User can choose a single layer visible, and then also they can turn on off as a group layer. Now I want to show you the comparison window. In the left side, the left map panel, and then the right side, the right map panel. And there is also the related charts and table will be here, you see. And then for this map, the related charts and table will be displayed here. And the indicator will be displayed for the left map in this side and for the right map in this side. The state filter also can choose differently. In the left map, user can select one state, and in the right map, user can select another state or the same state. And same goes for the municipalities. Let's make a comparison. We want to see the weekdays morning frequency in Saxony, and then weekdays afternoon frequency in Saxony. So this is the result, and this is the showing the details informations. Next, we want to comparison between the weekdays morning and Sunday morning from the disparity index map group. The details statistics also we see in the table, and we want to select it for president. It is clearly visible also in the map and also in the statistics that the values are different for weekdays morning and Sunday morning. Let's compare with the Dresden municipalities and Pinna. So here we see the disparity index for Dresden, and in the right side we see it for Pina, and also from the statistics it is visible that there is a difference between Dresden and Pina. So the difference is also visible for frequency indicator. So let's continue with the methods. Now we talk about the expert evaluation. The expert evaluation method is mostly effective for interactive map, and also when there is a small set of experts available. The participants are the experts of visualization and cartography. They have more than 10 years of experience in the field, and they didn't have any knowledge about the visualization tool before the assessment. And the assessment method started with the presentation with the demo, and we had open discussions. Then the participants had the opportunities to explore the interface, and then they answered some questions on interface interaction. They also rated utility and usability. There was 10 positive questions and seven negative questions about the tool. The result of expert-based evaluation is shown here. From the result, it is seen that the general outlook of the interface is preferred by the experts. And then for the visualization style, both of them selected dot map as their preference. And in the heat map, they had one like that, and another side they don't want to see heat map in the station level frequency. And same goes for disparity index map. One said that the current cluster outlier map, he want to see it in the disparity index. Another one prefer for local Moran index value. And from the utility rating, it is seen that the tool will contribute to spatial disparity analysis in public transit research. They agree with that, and they also agree that this is a novel approach of a visualization of spatial disparity in mobility service frequency. The average utility rate is 3.4 out of 5, and for the usability rate, for the average usability rate is 3.2 out of 5. And they also agreed that this tool offered the pop-up, which is adding extra value with the tool, and then comparison window was easy to use, and the tool maintained the cartographic principles. They also made some suggestions for the tool, and some of them implemented, some I couldn't implement due to time limitations. So the bookmark location, they wanted to have a bookmark on Dresden, so I bookmarked them on Dresden, and then also with that the performance got better. So we see the implementation note in here. And there are some challenges when we talk about the multi-source data, and when we harmonize these data for our studies. I have seen the challenges in missing data and also in geographical reference. For missing data in GTFS file, there are some locations that we don't have any informations on that area, and GTFS data normally updated in 7 days, but in every week there is some locations which is not which was in previous file, but in the next file that location may be missed. So there is no continuity of missing data locations in the format. And for geographical reference, OpenStreetMap comes with WGS 1984 projections, and then the administrative data from BKG is coming from with UTN zone 832. So I had to deal with this geographical reference carefully for the processing. And the overall research objectives were fulfilled by the first one we did with the literature study. And then the second research objective dealt with the data processing, which is resulting the reproducible workflow for the GTFS data. And then the final objective was fulfilled by the development of risk visualization, and also finished with the evaluation. There are some limitations in this study. when we started the study, the initial intention was to make it for whole Germany, which we did. We processed all the data for whole Germany, but grid level frequency, we couldn't do it for whole Germany because we had an ISO area interpolations technique. We took a lot of time, so we reduced the area to only VVU service area. And there are some challenges I have faced during the thesis. When we talked about during our ERP, I have got the feedback about do good, more focusing on visualizations, less focusing on the data processing, as we assume that we could use the previous tool which was developed in IOER, but it was seen that that tool couldn't be usable for the whole Germany level because that was only developed with a specific area. And when I decided to include regional transit data, I found that in the website, the previous data wasn't anymore. So I had to recollect the local transit and also regional transit data again. So I had to start at the processing steps from the beginning again. So it is recommended that if there is a possible